Here is the graph of y equals f of x. Sketch the graph of y plus 4 equals f of a half x plus 1. So first of all, I would probably rewrite this with that 4 on the other side. And while I'm rewriting it, I notice we do have a horizontal stretch and a horizontal translation. Is it in factored form? Yes, it's already in factored form, so we don't have to change anything. I'm just going to move that minus 4 over to the other side. Notice what I did with my brackets. I have like one set of brackets that's bigger, and then the ones that are inside are a little bit smaller. That can help you see which go with which. A little bit of labeling here. Can you see that that's a horizontal stretch? X by 2, the reciprocal. Here we have a horizontal translation. That's going to move 1 to the left. And finally, the minus 4 outside the function, so it's vertical. Vertical translation is going to go 4 down. Now, notice that as I'm explaining it, I paused at certain times. Like, it was like 1, and then I paused before I said left. So one of the things you want to do while you're taking notes is if you can predict what it's going to be, that's going to mean that you're starting to solidify what things are happening. You can go through a class where I'm just in copy mode. I just write down whatever the teacher says. Oh, they made a mistake. I made the mistake. I switch it. I just copy all the time. You're not actually engaged as much, and you're not going to learn as much that way. So in these times where like I'm hesitating a little bit, I'm wanting your brain to go, yeah, it's down, right? Or like 1 to the left, I'm wanting your brain to say something. I would much rather you said 1 to the right in your brain and got it wrong than just waited for me to find out what it would be. Because if you make a mistake and then find out about that mistake, then you're going to be like, I need to switch that. But if you just let it happen, then you're going to make those mistakes first on your quizzes when it actually matters for something, right? You don't get any deductions. I'm not like, oh, you thought right. I'm going to put that in my grade book. I could tell in your mind that you thought it wrong, so I'm just going to deduct you 5 marks today. Thanks for coming to class. No, that would be not good. Anyways, here we go. So now we've got everything set up. We can take some key points. In this graph, this is our 1 over x graph. Did you recognize it? It has an asymptote here. I'd like you to add it in with a dotted, if you have your red pen, perfect, and an asymptote here. They've labeled a couple of points. The key points in a 1 over x graph, I'm going to make the dots a little bit bigger, are these two. In fact, those are the only 2 points you need to do. I'm going to take 1, 1, and -1, -1. We do have stretches and translations. So I'm going to set up my transformations. I do all my stretches first. While going from left to right, can you see that we only have one of them? Your x values get multiplied by 2. And then translations next. We have 2 translations, 1 to the left, 4 down. So if I'm going to multiply my x by 2, my y values aren't going to change. And then if I'm going to move 1 left and 4 down, that'll become 1 and -3, -3, and -5. The other thing that you're going to do with a graph with asymptotes is check what happens to your asymptotes. So in this case, we had x equals 0, and y equals 0. If you multiply 0 by anything, does it change anything? No. The only thing that's going to affect these asymptotes is if they get moved left or right or up or down. Can you see that the x equals 0, which is your vertical one, when you move one to the left, it's going to become x equals -1. And your horizontal asymptote at y equals 0, when you move that 4 down, it's going to become y equals -4. So when you go to graph this, I like to graph these on a new grid. Especially with asymptotes, it gets really busy if you try to put too much on one graph. When I go to graph this, I would start with my asymptotes. So I draw my asymptote and label it at x equals -1. 1, 2, 3, 4. Draw my horizontal asymptote and label it at y equals -4. I look at my key points, 1, -3. And -3 5. Once you have your points, you can draw your graph towards the asymptotes, and you have the right shape. Does it look like it's been stretched horizontally, then shifted 1 to the left and 4 down? I think the stretched horizontally is a little bit hard to see in our points, because it still kind of looks the same kind of shape. But the moving of it 1 to the left and 3 down should be really obvious. This question was done in function notation, right? 1/2 x plus 1 minus 4. What does it look like in explicit notation? This equation is one of the ones we know, 1 over x. What is our blue equation? 1 over, now wherever the x is, that's going to be all of your horizontal stuff. What did we have inside the function? We had a 1/2 and an x. Is it plus 1? Yeah. That's all in the bottom where your x was. The 4 down happens outside of the function afterwards. For whatever reason, the reciprocal equation causes, can you see this just looks a little bit awkward? For whatever reason, because it's in the bottom of the fraction. It's a little bit harder, in my opinion, to see that that's inside the function, because there's not a square root to hold it inside or absolute values to hold it inside. Questions for practice on this one are 7 and 11. Yes. Oh, I did what I said I should always do, is read my question again when I'm done, but I scrolled down and I didn't read it. Thank you. What does it say? State the domain and range of each function. With our original one, this is a good one to do domain and range because it has asymptotes. Can you see that the domain was everything except for the one asymptote? So the way that we write that is we say x can't equal 0, but x is everything else. And our range is everything except for the asymptote, so we say that y can't equal 0. Y could equal everything else. On my blue graph, Now my domain has been moved over 1 to the left. Now x can't equal -1, but it equals everything else. And y can't equal -4, but it equals everything else. Thank you for rereading the question.